One of the things I often like to refer to, especially in statistics and probability, is a problem space. Researchers studying problem solving often thinking about problem processes in terms of mentally searching a quote-unquote problem space. And this idea is that every possible state of affairs within a problem corresponds to a node in a graph. The entire set of nodes occupies some mental area. So he gives you, or she does, Galati, this example of a goal state, the initial states, etc. That's not so clear. Let me try to draw another analogy. What is the probability of two heads when flipping two coins? And I hope you'll grant me that these four outcomes are the entire problem space. A head and a head, a head and a tail and a tail, and a tail and a head. The probability, therefore, of having two heads is 1 out of those 4. That's it. So I can multiply a half times a half and get 1/4, or I can just see the entire problem space. Now, to me, that's much more immediate and accessible than what she drew here, although it's an indirect suggestion of that. Now, there's a problem space for even the Tower of Hanoi problem, or is it Towers of Hanoi, that I can begin with one place, start, and then go to another place, etc., and basically graphically depict every conceivable permutation of actions, just as I'm depicting every permutation of actions with respect to flipping the two coins. It's the same idea, but just depicted in a different way. So these two authors' use of a problem space yields better solutions, but if we're overeager just to get a solution, it's not as productive. Now, they give an example that's a complicated rendering of a water tank problem. I'm not so concerned about that because the example itself is so involved about how to produce a particular solution from the water tanks. But the take-home message from that water tank problem is that those with specific goals had reduced effort on the task, but reduced ability to transfer it to other tasks. On the other hand, if I had a lot of expertise, I might be better at producing problem spaces from a new problem. So, for instance, we just spoke of two coins. That's my exhaustive list of all the things that can happen with two flips of a coin: head, 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 tail, 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 head. What if it were 3 coins? What's the probability of having all 3 heads? And the answer is 1/8, a half times a half times a half. Can I represent that with a problem space? Yes, as you can see. These are all the things that could possibly happen if I flip 3 coins. I could have head, 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 tail, head, etc. There's nothing else that could possibly happen. And I can quickly look at this and observe that the probability of having 3 heads is 1/8. This is an expansion of that idea of a problem space. I could do the same thing with 2 dice. What's the probability of having 2 ones if I roll 2 dice? It's 1/36, 6 times 6. And I could represent that with 2 dice if I so chose. I'm expanding that problem space. I can see that better. That should say excuse me, your grief. But you get the idea. So its expertise contributes to being able to graphically depict something. So the problem space hypothesis has been used to create expert systems, computer programs designed to model the judgments of one or more human experts in a field. These expert systems contain a knowledge base which stores facts that are relevant within that field, and they contain a set of inference rules that can help us make a decision. So now your author also gets into something called Muckraker. It's a particular program that helps investigative reporters, and it has a list of rules that you can look at, for instance, about whether a source is likely to cooperate based on a phone call, etc. I couldn't get a very good image of what Muckraker does. It's in your textbook, but the author just would not give me a good image. I could barely read this one. It's just, it's illegible. But the notion is that based on a problem space, the completely universe of outcomes, it'll help an investigative reporter on how he or she might pursue their job with respect to leads and making phone calls, etc. So expert systems are hard to develop, but they're needed because of limited supply. And the experts are also potentially biased. In the realm of poker, I'm reluctant to build this up because, or mention this even, because it's another gambling example. But the idea is that there's a finite universe of poker hands that can be played in narrow contexts. And there are things out there called poker solvers. In other words, if you're presented with one scenario, here's the cards that you should play and how you should play them, etc. So that's an expert system, if you will, that deals with an exhaustive array. Heck, I'm going to try to find it. Give me a sec. Sorry to keep you waiting. Thanks for your patience. This is a poker solver, and I'm not expecting you to take an interest in gambling or playing poker, but the idea is, come here, babe. Let me see if I can shrink this. Shrink that a little bit. Scooch it over. Well, I'm having a little problem here. You can only see a portion of it. Let me drag this out. Can I do that? Yes, I can. Oh, here it is. These are all the 2-card holdings that a player could have and what he or she should do under certain scenarios with respect to folding or betting or raising. Not to bore you with the details, that's totally irrelevant. But the suggestion is this is the entire problem space of all the cards that anybody could possibly hold. This covers everything, just like the coin example of flipping coins. So this is an expert system, and some players that use these things when they're playing internet poker are accused of cheating, which is, of course, a national crisis. I'm kidding. But that's the idea of this is another expert system that's based on this notion of a problem space.